8,498, 8,499, 8,000. Oh, hey, how's it going? Didn't see you there. Just doing some exercising with my 800-pound dumbbells. That's right. But don't you worry, your tickets are in the mail. Tickets to the gun show. Now that we got the exercise out of the way, let's learn some math. Today we're going to talk about algebraic properties and writing algebraic proofs. Now, one of the most important questions we have to be able to answer when we're working with this is the question of why. Were you a kid like this when you were little, asking your parents, why? 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 Well, sometimes asking why is actually a good thing. And that's really what we're going to be focusing on here in Target 5. In the first part, we're going to learn some properties, and in the second part, we're really going to work on applying them in some proofs. Now, if you're the parent of this child, though, maybe asking why isn't always a good thing. We can see here from this cartoon that curiosity is not just bad for the cats. However, today, when we're talking about our properties, that's what we've got to keep in mind, is these properties are going to help us answer the question, why? So let's dive right in here. Our first property is a property you might be familiar with. It's the distributive property, which says if a quantity can be multiplied by an expression in parentheses, then that quantity can be multiplied by each term of the expression. And that's a lot of words. So let's look at an example to maybe make this a little more clear. So we've got 7 outside the parentheses and our trinomial 3x plus 8y minus 4 inside our parentheses. So we have a quantity outside 7 and our trinomial inside has 3 terms. So what we can do is distribute the 7, multiply the 7 to each term inside here. So we end up with 7 times 3x, 7 times 8y, 7 times 4, which gives us 21x plus 56y minus 28. We'll practice this more in just a little bit. But let's talk about our second property, and that would be the substitution property. Now, some of you might have just been watching the World Cup or some other soccer, and when they want to make a sub, one guy comes to the sideline and another comes running up and they stand next to each other and they can make a switch. One guy goes into the game and one guy leaves the game. But here's the deal. When they make a substitution, do they substitute a forward for a goalie? No, right? They're going to substitute a goalie for a goalie or a forward for a forward. You want to substitute things that have equal positions in soccer, in basketball, and football, whatever sport you're playing where you're making a substitution. Math is no different. If two quantities are equal, then the quantities can replace or substitute for each other in an expression. Let's take a look. Here we've got 2x squared minus 7x plus 8. Now, there's really nothing we can do to that expression as it is. There's no like terms, and no, we can't do the multiplication. But if we know that x is equal to 4, so x and 4 are both goalies, what we can do is take x out of the expression and replace it with a 4. So it would look like this, 2 times 4 squared minus 7 times 4 plus 8. Once we get here, it's a matter of our order of operations. Exponents, then multiplication, then we would do subtraction and addition. And it would look like this. You can see once we substitute, now we can actually simplify our expression all the way down to one term, down to 12. So, now that we've talked about our first two properties, let's give them a try on our own. You've got 4 expressions here that I want you to fully simplify. Notice each one is going to have you use the distributive property. Also be careful though, remember what we learned last set of notes, that you're not fully simplified if there are any like terms still remaining in your expression. So go ahead and pause the video and give these a try on your own. Ready, go. Welcome back. Let's see how you did here. So you can see the correct simplified expression is there in green. You can see in number 2, we had to watch out for our ninja coefficient. There's really a 1 hiding out there. And you can see in 3 and 4, we had to combine some like terms. For right now, the order that you wrote the terms doesn't matter. So if you put the 4b first and the negative 3a second, like in number 2, that would be okay. So now that we've practiced the distributive property, let's try our substitution property. We have 2 expressions here which have variables, which prevents us at the moment from doing any simplifying. But we know that a and 6, 3 and b, and 2 and c all play the same position. So they can be replaced or substituted. So what I want you to do is go ahead and make the substitution, use our substitution property, and then simplify each expression using order of operations. Ready, pause. Let's see how you did. Check the work there. You should have gotten 13 for number 1 and 20 over 3. Notice we left it as a fraction. That's okay. Fractions are not evil. I know you might think so, but we're going to work with them a little bit more later in this unit. Help us out with that a little bit. But you can see 20 over 3 is our final simplified answer, and that's okay to have it as a fraction. So Those are two of our properties, and probably two of the ones we're going to be using the most throughout the year. But we still have a number of other properties that we need to look at. First one is the commutative property. Now I put a picture of a traffic jam there because a lot of your parents might commute to work, which means they're changing positions, changing places from home to work. And that's what the commutative property is about. The order you add terms or multiply factors doesn't matter. Let's take a look at what I mean by that. You can see if I add 5 and 2 or 2 and 5, I get the same thing. The order of those two terms doesn't matter. Same thing with multiplication. Negative 3 and 4, 4 and negative 3. Doesn't matter the order. I can switch the order. I can commute the order and stays the same. Notice I only said, though, addition and multiplication. With subtraction, we can see if we change the order of the 5 and the 13, we don't get the same thing. So that's a no-go for the commutative property. Same thing with division. 18 and 6 can't be switched and end up with the same answer. So we know that those won't work. Let's talk about the associative property here. The associative property tells us the order we will perform addition or multiplication doesn't matter. So if I have an expression where all of the operation is addition, such as 8 plus 4 plus 10, I have two different addition symbols there. Well, which one do I do first? Well, I could go left to right, but what we can see our associative property tells us is it doesn't actually matter as long as it's all addition. So I can do 8 plus 4 and then add 10, or I can do 4 plus 10 and then add 8. I'll end up with 22 either way. The same deal applies with multiplication. As long as it's all multiplication there, I can do 7 times 2 and then multiply by negative 5, or 2 times negative 5 and then multiply by the 7. I will end up with the same thing. The same deal, though, applies with the subtraction and division as it did with our commutative property. They do not work with the associative property. If you don't believe me, go ahead and take these two expressions and take out the addition and multiplication and put in subtraction and division and go ahead and try them. See if you end up with the same thing. I can guarantee you, you won't. So we've hit 4 out of our 10 properties. Now what we're going to look at is a bunch of properties here that you have probably been using probably since like first grade when you first started learning how to add, subtract, multiply, and divide. And you didn't know you were using these, but you actually were. So let's look at them here. First one is our multiplicative identity property, which says if a value is multiplied by 1, the product is the same value. 8 times 1 is 8. 100 times 1 is 100. A billion times 1 is still a billion. That's our multiplicative identity property. And you've multiplied by 1 probably a lot in your life. Multiplicative inverse property, still dealing with multiplication, but now if a value is multiplied by its reciprocal, the product is 1. Instead of multiplying by 1, we're going to be equaling 1. So if we have two numbers, we can see here 2/3 and 3/2, and they're equal to 1, we know that they are multiplicative inverses or reciprocals. And that also we can go the other way. If we know it equals 1, we know the two numbers have to be reciprocals or multiplicative inverses. Our multiplicative property of 0. This is everybody's favorite multiplication problem because anything you multiply by 0, you're going to end up with 0. The product is going to be 0. It doesn't matter how big or how small the number is, 0 multiplication ends up being 0. Now the 0 product property is very similar, except what it says is if we know we're going to end up with 0, but don't know what the two things we multiplied were, we can know that at least one of them has to be 0. So if we have x times y, now I don't know what x is, I don't know what y is, but I do know that they end up equaling 0. Well, what that tells me, the 0 product property tells me, is that either x is 0 or y is 0, or they're both 0, but at least one of them has to be 0 for this equation to be true here. The last two deal with addition. So our additive identity property says if any value is added to 0, the sum is the same value. Pretty straightforward, and you've probably done this a lot. As our example says there, -6 plus 0, it stays exactly the same, the identity, -6. The last one is our additive inverse. Now the inverse, we're still using the same word, but it's going to change a little bit here. Instead of looking for reciprocals, we want to find the opposite of a number and add them. So -15 and +15, those would be opposites. When we add them, we get 0. 100 and -100, opposites. We'd add them and we'd get 0. So these are our last 6 properties here. And again, as you look at these, you've probably used these properties before and didn't even know you were using them. So let's apply our properties now. Now we're going to ask the question, why? So we can see in each expression here, we start with an operation and then it's simplified in some way. It's changed in some way. And what I'm asking you is, why? Why did that happen? what you have to be able to answer me with is one of the properties we just learned. So look at each of these and try and decide what property was used to change or simplify each of these expressions. So go ahead and pause the video and give these each a shot. Ready? Go. Let's see how we did here. So under each of these, you can see what property was used to simplify or change each of these expressions here. If any of these didn't make sense to you, if you're totally confused about any of these, please, please, please write it down, circle it, whatever on your notes, and make sure you come tomorrow with questions, because we have reached the end. And if you don't get this picture, it probably tells me you've never taken Mentos and put them in a bottle of Coke before. And if you haven't, I think I know what you're up to tonight. So with that, we'll see you next time.